So we'll move on to the next one. Here, this one you can also do with substitution because we have one of the 4 starting points.
Okay.
So, for example, here we have this one where you have a 1, a positive 1 with the y. So you could also do this as substitution, but this one would be faster if you use elimination. If you multiply everything here by 5, it'll equal the equation on the bottom, so it's actually the same equation. You could either do it that way, you could either multiply the top equation by 5, or if you have this option to divide a GCF and make the equation easier to work with by making the numbers smaller, that's also a good way to do it. Because this has a GCF of 5, you'd be dividing everything here by 5. And so it ends up being 2x plus y equals 5. Line these up, and you see it's the exact same equation twice. So this is where you would say that you have infinitely many solutions. If you did want to increase the numbers, because that's the normal strategy,
Yeah.
then you'd want to see which one do you want to eliminate. Normally it's easier if you pick the one where it's just got the coefficient of 1. So we focus on the y, for example, and make it the opposite of the 5y on the bottom. So then you'd multiply this by -5 so that you can use elimination. And if you did that, this would turn into, from distribution, we'd have -10x minus 5y, and that equals -25. This one, you just line it up underneath it.
Okay.
And so we're specifically eliminating y this time. And they're exact opposites. The 2 y terms are exact opposites of each other, so this is ready. You might also hear this process called the addition method. Right here, we're going to do the addition part, where you add these going straight down. So these will cancel each other out. This would be a 0x.
Okay.
Or you could just say 0. Same thing here. This will cancel out, and it'll be 0. You don't even have to write the second 0, you could just leave it as 0. And on the right side, these will cancel each other out. So 0 equals 0. This is the other way that you can see that we have infinitely many solutions. Basically, there's nothing that makes these different from each other.
Okay.
And that's why they're the same line with infinitely many solutions. And remember, you could always do this with substitution as well.